Once you accept that you should lower the learning rate during training, one question remains. How exactly should it come down? The old answer was step decay, dropping it in sudden cliffs every few epochs. But there's a smoother, more elegant answer that is quietly taken over almost every state-of-the-art run. Instead of cliffs, you glide the rate down along a cosine curve, from its peak all the way to near zero. It's called cosine annealing, and it consistently matches or beats hand-tuned schedules with fewer knobs. In fact, it's now the default in most modern vision and language training runs. Let's see why the curve works so well. First, let's put step decay right next to cosine annealing and see the difference. Step decay lowers the rate in abrupt cliffs. You train at one value, then suddenly slash it by a factor, train some more, then slash it again. It works, but those sudden jolts are jarring, and you have to handpick when each drop happens and how big it is. Several knobs, and all of them guesswork. Cosine annealing instead traces one smooth curve. The rate follows the gentle shape of a cosine from 0 to pi, easing down continuously, fast through the middle of training and slowly near the start and the end. No cliffs, no hand-picked drop points, just one graceful descent all the way to near zero. So how does the curve actually play out over a run? Walk through its shape, stage by stage. Many runs open with a short warm-up, ramping the rate up from near zero to its peak over the first few steps. This steadies the early, unstable phase before the annealing proper even begins. It's optional, but it's common in modern training recipes. From a peak, the rate follows the cosine curve smoothly downward. It falls slowly at first, then quickly through the middle of training, then slowly again as it approaches the bottom, tracing that gentle, continuous half cosine shape the entire way down. The steepest drop lands right in the middle, where the model has already found a good region and can safely accelerate its descent. Near the end, because of the curve's shape, the rate lingers at very small values for a good while. This is where the model finally settles, making tiny, careful adjustments that ease it into a sharp, low minimum instead of bouncing around it. Optionally, you can restart. Jump the rate back up to the peak and anneal down again. Each restart lets the optimizer escape its current basin and explore a fresh region, and saving the model right before each jump gives you a free ensemble of diverse snapshots. Strip it down, and 3 ideas define cosine annealing. The heart of it is lowering the rate along a smooth cosine curve from the peak down to near zero. No abrupt cliffs like step decay, just one continuous descent that avoids sudden jolts to training. Because the curve flattens near the bottom, it lingers at very small rates toward the end. That extra time at tiny steps lets the model finally settle into a sharp minimum, which is a big part of why cosine schedules generalize so well. And with warm restarts, it periodically leaps back to the peak and anneals again. Each cycle escapes the current basin to explore elsewhere, and snapshotting before every restart yields the snapshot ensemble's trick, several diverse models for the price of one run. All right, let's lock in what matters. Cosine annealing lowers the learning rate along a smooth half cosine curve, from its peak down to near zero over the course of training. Unlike step decay's abrupt cliffs, it decreases continuously, fast through the middle and slowly at the ends, and spends extra time at tiny rates to fine settle the model. Cosine annealing with warm restarts periodically jumps back to the peak, letting the optimizer escape basins and yielding a free ensemble of snapshots along the way. With fewer knobs than hand-tuned step decay, it's become the default across modern vision and language training. So you usually just set the peak rate and the total length. If breaking down the machinery of modern AI like this appeals to you, there's much more to explore at standardy.com. Come join us.